mass spectrometry. This technique is used to determine the molecular mass of the molecule. Now, the principle of the mass spectrometry is when electrons are bombarded on the molecule, then it gives the formation of different fragments. Now, these positively charged fragments, they are accelerated towards the negative electrode and finally falls on the detector. Now, after formation of the fragments, these positive ions, they have different masses, and according to different masses, they get separate from one another and they falls in the different places in the detector, and detector gives the response for particular mass, and then it observed on the spectra. And from the spectra, we observed the line spectrum here, and the height of the line is depend on the number of ions strikes there. Here, the ion produced are accelerated in an electric field having voltage V, and energy acquired for the particle in terms of the kinetic energy. Therefore, kinetic energy half mv square equal to EV, where small v is the velocity of particle, m is the mass of particle, E is the charge on the electron, and V is the accelerating voltage. Now, from this equation, we can calculate the V is equal to square root of 2 EV upon m. Now, kinetic energy for each and every particle is near equal to the half m1 v1 square, because mass of the ion, V is the velocity of that ion, and from this we can calculate the kinetic energy of each molecule. Now, when these molecules, these ions, when traveling towards the magnetic field, then magnetic field is also have an important role, and with respect to this magnetic field, how they going long in the mass analyzer is dependent, and therefore a charged particle have been accelerated by an applied voltage. They entered in the magnetic field B. The particle moves by BeV and by centrifugal force around the path, and from that we can calculate the R, the value of R, how it move from one place to another. According to this difference in the R, they get separate from one another because of the difference in the masses. Now, sequence of the instruments, we know that there are 4 parts of the instruments. First is a sample inlet, then ionization chamber, then mass analyzer, and finally on the detector. Now, this is the instrument where flow chart, where sample is directly transferred to the ion source, or it may be coming from the GC, outlet of the GC, that is eluent of the GC, transferred to the ion source. And after that ion source, the mass filter or mass analyzer, where the elements, they get separate from one another. The higher heavy ions, they are going longer distance, and less mass ions, they are coming to the short distance. In this way, they get separate from one another, and in the peak, we observed that the line graph is observed. The intensity of the line is depend on how many number of ions strikes at the at that particular mass, and the mass is given on the x-axis, and on y-axis it is a height. Now, the types of ionization, the first important part, that is the ionization. There are 6 types of ionization methods are available. First is the electron ionization method, chemical ionization method, then fast atom bombardment and secondary ion mass spectrometry, then thermal ionization, atmospheric pressure ionization and electrospray ionization, that is API and ESI, and matrix assisted laser desorption ionization, that is a MALDI technique. Now, these techniques, initially it was suggested that the molecule should be in the gaseous state, but nowadays we can use the solid, liquid, gas material. For solid material like polymers, peptides, all these heavy molecules are also analyzed with the help of MS because of these ionization techniques. Now, in case of the first ionization technique, that is a electron impact ionization, here electron impact ionization is a sample molecule will be bombarded by the electrons having the energy 70 electron volt in the ion source. This results in the breaking down the bonds in the molecule and to give the formation of small fragments. Each fragment will have the specific mass number, and then they travels towards the accelerated towards the opposite electrode. Now here in this technique, what happened? The ions, they are molecule coming from this side, and the electrons, they are coming from this side, and they get interacted with this molecule, and immediately it gets converted into the fragments and then transferred to the detector like quadrupole detector, and the lines are observed. This is the example for the methyl stearate molecule. Here the lines are observed. Here the very small fragments are formed, and we observed on the graph the number of lines. Now in case of the characteristics of the electron impact ionization method is related to the this method is a hard ionization technique. Sample molecule undergoes the severe fragments. It produces a complex mass spectrum because there are so many fragments are formed, therefore number of lines are increases, and therefore it is a complex spectrum, that is number of lines are there to interpret. It's difficult. It provides the structural information of the sample. Now in case of the chemical ionization method, this technique is a soft ionization method, because here the directly molecule is not bombarded by the electron. Initially what happens, some different molecules are first bombarded by the electron, and it gives the formation of positive ion, and this positive ion molecule then chemically interact with the respective sample material, and then it gives the formation of charge transfer on that, and it gives the formation of positive ions. Now here the positive chemical ionization and negative chemical ionization, such a type of two chemical ionization methods are available. The positive chemical ionization method, here positive ions are formed by bombardment of the molecule with the electron, and it gives the positive ion, and then this positive ion treated with the molecule to give the positive ion transformation. Now normally the molecules which are initially used as isobutane, methane, ammonia molecules, they are initially bombarded by the electron to give the formation of the simple ion, and then chemically react with the molecule to give the just only the positive ion get transferred on the molecule, and it gives the formation of one molecule ion. Initially in case of the electron impact method, what happened, the molecule is bombarded by the electron, and we get the formation of number of fragments. Here what happened, we observed the single fragment. The only one electron is ejected or only one proton is added, therefore one charge on the molecule is formed, and therefore we observed the simple graph and than the electron impact method. Now this method is a very soft ionization technique. It produces a simple mass spectrum with a relatively less number of fragments ion. Then it provides the accurate information about the molecular weight of the compound. Now we observed that the same molecule, when we observed with the electron impact ionization method and positive chemical ionization method, here the same molecule gives the number of fragments are there. Here the number of fragments are very less, and therefore we observed that here the last peak where one electron is ejected, but here one positive charge on that, the height of the peak is increases because all other molecule fragments are less, and this molecule this ion gives the maximum peak. And therefore here we very small ion is observed, and therefore it is a very difficult to find out the exactly in the one stroke, and therefore chemical ionization methods are very important, very simple methods. In case of the positive chemical ionization or negative chemical ionization, here just only we are changing the electrode. Here instead of positive chemical ionization, negative chemical ionization method is used. Here negative ion is transferred or generated on the molecule, and that negative ion get accelerated towards the positive electrode and then get measured. The next ionization method is the thermal ionization method. Here what happened, the molecule is heated with the help of thermal coil, and then when gaseous molecules are passes through the thermal coil, then it converted into the ions, and then these ions are get measured, and therefore this method is used as a thermal. The next is the fast atom bombardment method. Here beam of the electron is continuously fall on the molecule. Now the molecules are placed in the capillary tube, and here on the molecule the continuously electrons are bombarded, and gives the formation of sputtering of the ions are formed, and these ions are directly transferred to the mass analyzer. In the same way as in case of the SIMS, that is the secondary ion mass spectrometer, the same thing is happen with the molecule. Here liquid molecule or solid molecule can be used for the bombardment. Now third is the for peptide and protein like molecules. These molecules are for this molecule we can use the atmospheric pressure ionization and electrospray ionization method. Here atmospheric pressure is get changed after certain time, and then the electrons are get bombarded on that, and immediately we observe that the separation of the peptide and proteins, the positive ions are formed, and these positive peptides and positive proteins, generally what happens, the negative ions are on the protein, but positive ions are formed, and these positive ions are get collected. In case of the some high polymer or protein molecules, what happens? These molecules are not dissolved or in the transfer, cannot transfer into the gaseous state. For this purpose, the molecules are coated on the glass plate, and on that, from the laser light, it continuously bombarded on that, and immediately what happens? Some matrices and analytes are formed, and these matrices and analytes having the charges, and these charged ions, they get analyzed with the help of mass analyzer, like a MALDI technique. Now, the third point, after formation of the ions, the mass analyzer is most important factor. Here, it is an integral part of the MS, which is responsible for the separation of the ions produced in the ions source and basis of the mass number. Now, in mass analyzer, what happens? The magnetic sector mass analyzer can be used, quadrupole mass analyzer can be used, ion trap mass analyzer is used, ion cyclotron resonance analyzer is used, time of flight mass analyzer can be used as a mass analyzer. This is the mass analyzer, magnetic sector mass analyzer. What happens when ions are bombarded with the electron? The heavier ions are formed, some smaller ions are formed according to the masses, and according to these masses, they get separate from one another, and we observe that the bigger size molecular ions, they are going long distance because R is very high as compared to the smaller ions. In terms of the R is equal to with respect to the electric field and magnetic field or charge, they get separate from one another, and according to the magnetic field, they get bigger or heavier molecule ion, they go longer distance and they strike on the detector at different places, and we observe the different lines. Another most popular analyzers are quadrupole mass analyzer and ion trap mass analyzer, out of which quadrupole mass analyzer is mostly used in case of the organic compounds. Here the DC voltage and AC voltage are utilized in the quadrupole mass analyzer. Here we observe that there are 4 rods are there. Now, out of which the 2 rods are connected to the DC supply, and these 2 rods are connected to the AC supply, and the DC and AC ratio is maintained in such a way that the one of the molecule with a specific mass number only allowed to travel through these 4 rods and strike on the detector, and on the graph only single line is observed. Now, in this quadrupole analyzer, we observe that this is the quadrupole analyzer. Here 4 rods are there, and these 4 rods, before that the pre-rods are also there. Now, the AC to DC ratio is maintained. According to that, what AC to DC ratio is there, according to this, the which type of only ions are traveled towards the detector is dependent, and therefore the other molecular ions, they are coming from the ion source as a fragmented or ion source, they are trapped here in the pre-column, and only single ion is get travel to the this is the AC and DC supply. This is the positive, and this is the another positive. This is negative. This is negative. Now, between this positive negative and between this positive negative, the molecular ion get changed, and according to that, they get moved towards the detector. Now, this is the inductivity coupled plasma mass spectrophotometer. Here, we can use this technique for the inductivity coupled for a specific application. Ion cyclotron resonance. This is also one of the mass analyzer. Here, the ICR trap ions in a small sample cell with the high mass resolution is observed.